Welcome to class 7 mathematics classes. We are in fundamental geometrical concepts. Today we are going to do exercise 16a. Question number 1. Answer the following questions. Number 1. How many end points does a line segment AB have? So this question is talking about a line segment. So let us draw one line segment. This line segment, okay. AB is the name. AB is the name of the line segment. Now it has starting point here and end point here, okay. Starting point here and end point here. It starts from A and ends at B. So there are two end points of this line segment, that is, one is this end and another is this end. So there are only two points in a line segment. Okay. Now, how many endpoints does array AB have? Okay. For this, let us draw a ray at first. So we know a ray is starting from A and moving to one direction. So this is a ray AB. Okay, it starts from A and it moves towards this direction, and where it ends we don't know. So it has one end point. Therefore we can write there is only one end point in a ray AB. Okay, ray AB is written as AB and just above this an arrow. Okay, here AB bar. 3 number how many endpoints does a line have? So first of all, let's make one line. Line extends both the sides. So one arrow here, one arrow here. So for a line, we don't have starting point, and we don't have end point. Where it ends we don't know, as the line comes from somewhere, okay, and it is moving towards both the direction. Okay, this direction also it is moving, and this direction also it is moving, and we don't have any starting point here of the line, and we don't have any end point of the line. Therefore, what we can write, a line do not have end points. Okay. 2 which of the following has a definite length? Okay, number 1 is AB arrow above, number 2 is AB arrow at both ends, and number 3 is AB bar. So what this represents, this represents a ray. A ray has one endpoint and it moves in one direction and has no endpoint. Okay, so therefore it is not having definite length. This is a line, it represents a line. A line extends both the ends, so it does not have definite length. This is a line segment which has starting point and end point. It has starting point and end point. So therefore it has definite length. AB bar has two endpoints and it has definite length. Okay, now question number 3. How many lines can be drawn to pass through two given fixed points P and Q? Okay, how many lines can be drawn to pass through two given fixed points PQ? Suppose here one point P, another point is here Q. Okay, so let us join these 2 points, okay, by a line. So we can say that only one line can be drawn through these 2 points, isn't it? If I draw line passing through this point P, it will not meet Q. If I pass a line through this point Q, this will not meet P. So the possibility is only one, that one line can pass through these 2 points. Okay. Question number 4. How many lines can be drawn to pass through a given point? Okay, given point. So let us make one point here. Now just think how many lines can be drawn to pass through this point. Okay, so here you can see one line passed, two line passed, three line passed, four line passed. So here as many as we can draw. Therefore we can write unlimited lines can be drawn through a given point, through a given point. Okay, question number 5. A fixed point P is given. A fixed point P is given. How many ways, no, how many rays can be drawn with P an initial point? So here a fixed point P is given, a fixed point P is given. How many rays can be drawn through P as an initial point? Okay, so through this point how many rays can come out? Okay, let us draw few rays. 1, 2, 3, 4. Okay, so here you can see as many as we wish we can draw rays. These all are rays, these all are rays, okay, coming out from this point P. So here what we can say, unlimited rays can be drawn. Okay, with P as an initial point. Question number 6. Draw a line segment of 5.3 centimeter. So we can draw a line segment using a scale, isn't it? Using a scale. Look at here, you can see this as I have taught you in my previous class. So we'll take from 0 mark here, and 5 is here. So from 5, you can see here, see 5 and 1, 2, 3. Okay, so 5.3 is up to this, starting from here. Okay, so let us draw from here. It starts and 5, 1, 2, 3. Okay, so this way we can draw a line segment of 5.3. We can give a name also. The length of this line segment is 5.3 centimeter. Question number 7. Mark P, Q, R, X, Y, Z such that P, Q, R are collinear and X, Y, Z are not collinear. Very simple. Okay. Collinear, you know, only points lying on same line. So let us draw one line here and let us give three points P, Q, R. So P, Q, R collinear, and here one X, Y, Z, X, Y, Z, and they are not collinear because they are not on the line. Okay, on the same line they are not there, that is why they are not collinear, and PQ are on the line, therefore they are collinear. Now question number 8. How many lines can be drawn through three? Number one is collinear point and number two is non-collinear points. So here you can see, from suppose these three are collinear points. Okay, so only one line can pass through these three collinear points. You can see this. Okay, three are collinear points lying on the same line. Okay, so one line can only pass through these three points. And here suppose these non-collinear points. So here how many lines can pass through these three non-collinear points? You see here, this is one line, here is another line, here is another line. So three lines can be drawn, okay, through three non-collinear points. So let us write here one line can be drawn through three collinear points. Okay, and here three lines can be drawn through three non-collinear points. So now next is question number 9. Okay, I think you have understood this. Question number 9 is, what is the maximum and minimum number of points of intersection of three lines drawn in a plane? Okay, so what is the maximum number of points of intersection of three lines drawn in a plane? Okay, maximum number. Let us draw three lines on this plane. Okay, one, 2 and 3 lines. So you can see here the point of intersection 1, 2 and 3. So that is why we can say maximum intersection of 3 lines is 3. Okay, now let us draw 3 lines here. 1, 2, 3 lines. Okay, so these 3 lines are parallel to each other, line L, M, N. So there is no intersection only. So minimum intersection of 3 lines drawn in a plane is 0. So let us write minimum intersection of 3 lines is 0. So we have completed exercise 16. In my next video class, we'll start a new chapter. Thank you very much.